this class, we'll be talking about how to add and subtract rational expressions. And again, rational expressions are fractions. So I want to refresh your memory on how we add and subtract fractions. So really quickly here, recall that to add and subtract fractions, or to add or subtract fractions, they must have the same denominator. And if they have the same denominator, we simply add or subtract, hold on, let's say it's A over C plus B over C. We add the numerators and keep that common denominator that they both have. If it was subtraction, A over B minus, A over C minus B over C, this would be A minus B over C. So if our denominators are the same, life's great. You add the numerators, do not add the denominators, keep the common denominator. Subtract the numerators, keep the common denominator. And then simplify if possible. Okay, so we'll start off by looking at addition and subtraction of rational expressions that have the same denominator. And then, of course, most of the rational expressions we look at won't necessarily have the same denominator. So we'll talk about how we can find the least common denominator, or the greatest common factor, or least common multiple, of the denominators, and then use that to help us make a common denominator and then add and subtract. All right, so part one, introduction, this kind of simplifies what I just said, but in fancier function notation. To add or subtract rational expressions with the same denominator, we add or subtract the expressions in the numerators, and then keep the same common denominator. All right, there are 4 examples done here for us. We'll look at the ones that are done here, and then we'll jump to the examples after this. So if we have something like 2 over x plus 4 over x, both of these expressions have a denominator of x. To simplify this, we add the 2 numerators together, 2 plus 4, and write them over the common denominator, x. So this would be 6 over x. That one can't be simplified anymore, so we're done. 6 over x would be the answer there. Okay, for part B, 6x plus 3 plus 3x squared, 6x plus 3 over x plus 1 plus 3x squared over x plus 1, both have a denominator of x plus 1. So to simplify this, we'll add the numerators and write them over x plus 1. Let's go down to that one. All right, so if we add these numerators together, 6x plus 3 plus 3x over x plus 1. Now here, it does look like our numerator is a trinomial. We might be able to factor it and simplify things. Let's see. So if we write this in standard form, the 3x squared plus 6x plus 3 in the numerator over x plus 1, we see that in the numerator, we can factor out a 3 from everything. So that would be 3 times x squared plus 2x plus 1. And then x squared plus 2x plus 1 can be factored more. That's x plus 1 times x plus 1. So after adding, our numerator ends up factoring to 3 times x plus 1 times x plus 1. Our denominator is in x plus 1. So x plus 1 cancels out, and we're left with just 3 times x plus 1 as our answer. So even if you have common denominators, that's easy for adding, but after you add, you have to simplify. So factor as much as you can, and then cancel out common factors. All right. The next one kind of works out similarly when you add and you factor. For x plus minus 1 over x plus 1 and x squared minus x over x plus 1, we're adding everything together. So we get x minus 1 plus x squared minus x over x plus 1. We simplify that, the x's cancel out, and we have -1 plus x squared. Or if we rearrange those terms, that's x squared minus 1 in our numerator. X squared minus 1 over 1. The numerator factors to x minus 1 times x plus 1, and then the x plus 1 in the numerator cancels with the x plus 1 in our denominator. So x plus 1 is our final answer. All right, and then the last one we're asked to look at, we're adding 2 over a minus b plus -1 over b minus a. Here, it doesn't look like our denominators are the same. It doesn't look that way at all. One's an a minus b, one's a b minus a. But remember, those expressions are opposites of each other, and we can just factor out a negative from the denominator, and then if we factor out the negative, our denominators become the same. So for that second expression, -1 over b minus a, that's -1 over -a minus b, and then we can cancel out the negatives, so that expression is a 1 over a minus b. So adding 2 over a minus b plus -1 over b minus a is equivalent to 2 over a minus b plus 1 over b minus a. These two expressions are equal. Okay, now that we see our denominators are the same, we just add the numerators. 2 plus 1 is 3 over a minus b. Can't be simplified anymore, that's it. All right, we're gonna jump into a couple of problems. All right, for part A, if we have 3 over xy plus 4 over xy, our denominators are the same. So this would be 3 plus 4 over xy, which is 7 over xy. This can't be simplified anymore, so that's our final answer. All right, on to B. 10x minus 75 plus 5x squared, over 5 plus x plus 5x squared over 5 plus x. Our denominators are both 5 plus x, so we can add the numerators together. 10x minus 75 plus 5x squared all over x plus 5. This numerator is a quadratic trinomial, so we can write it as 5x squared plus 10x minus 75 all over x plus 5. And then it does look like this one's going to simplify a little bit more. First, we can factor out a 5 from the numerator. Okay, and then that's still over the x plus 5. Last step. X squared plus 2x minus 15. That's going to factor to an x plus 5 times x minus 3. Now we can see that the x plus 5 in the numerator cancels with the x plus 5 in the denominator. And our final answer here, would be 5 times x minus 3. All right, next problem. For C, we have 7x minus 18 over x plus 3 plus 2x squared minus 7x over x plus 3. We add the numerators, 7x minus 18 plus 2x squared minus 7x, and write that all over x plus 3. Let's see, our numerator simplifies to 2x squared plus 7x minus 7x, so those 7x's go away, and we get minus 18 over x plus 3. And then we want to try to factor. First, in our numerator, we can factor out a 2 from both of those terms. That gives us 2 times x squared minus 9 over x plus 3. And then x squared minus 9 is a difference of squares. So the numerator factors to 2 times x plus 3 times x minus 3, and then it's over the x plus 3. So again, here we see that our denominator cancels out with one of the terms in the numerator, and we're left with 2 times x minus 3. Then on to part D. Now this is the one where we have to be a little careful with our denominators. We see here we have x over x minus y, and then minus negative y over y minus x. X minus y and y minus x are opposites. We can just factor out a negative from one of the denominators to help us simplify a little bit better. So let's write out what this should look like. We'll leave the first term the same right now, x over x minus y, and this will be minus negative y over y minus x is negative x minus y. All right. Then we see we have a lot of negatives going on there. I am going to cancel out the negative with the y with the negative in the denominator. And then this expression just simplifies to x over x minus y over x minus y. All right, now that our denominators are the same, this is just x minus y over x minus y. Oh, would you look at that? Which equals 1. All right, these are all examples of adding rational expressions with the same denominator. Next, we're going to jump to some practice exercises on subtracting rational expressions with the same denominator. All right, so there's a little box here that tells us what to do, but it's subtract the numerators, keep the common denominator. All right, the only thing you have to be a little extra careful about here is, remember, if you're subtracting the second numerator, you have to subtract all of the terms. So for part A, we're just subtracting a 14, that's not bad. For part B, we're just subtracting a 9. But for part C, you'd have to subtract that negative 3x and subtract the 6. So make sure you subtract every term in the second numerator. Let's go through and do these examples so you can see what I mean. So for the first one, 2x plus 28 over x plus 7 minus 14 over x plus 7. This would be 2x plus 28 minus 14 over x plus 7. The numerator then simplifies to 2x plus 14, because 28 minus 14 is 14, over x plus 7. And then we can factor out a 2 from the numerator. So we have 2 times x plus 7 over x plus 7, which gives us a final answer of just 2, because the x plus 7s cancel out. For part B, 4a squared over 2a minus 3 minus 9 over 2a minus 3. Denominators are the same. We can go straight to subtracting the numerators. 4a squared minus 9 over 2a minus 3. And then we want to factor. The numerators, the numerator that we have here, 4a squared minus 9, is a difference of squares. The first term is 2a all squared. The second term is 3 squared. So this would be 2a plus 3 times 2a minus 3 divided by 2a minus 3. Then we see here, of course, the 2a minus 3's cancel out, and our final answer is 2a plus 3. All right, last one, x squared minus 2x over x squared minus 4 minus negative 3x plus 6. So on this one, our second expression, the numerator has more than just one term. Please be careful, make sure you subtract each of those terms. So I'm gonna write this out. It's x squared minus 2x minus, we're subtracting this entire numerator, negative 3x plus 6. And then it'll all be over x squared minus 4. We're gonna have to distribute this subtraction to each of these terms. So our numerator ends up being x squared minus 2x plus 3x minus 6. And then it's all over x squared minus 4. Simplifying that numerator just a bit, that's x squared plus x minus 6 over x squared minus 4. We're running out of room below, so we'll write to the side here. This factors to x squared plus x minus 6 is x plus 3 times x minus 2. And then x squared minus 4 is x plus 2 times x minus 2. The x minus 2's cancel. And finally, we're left with x plus 3 over x plus 2. All right, so when you're subtracting, make sure that you subtract every expression in the second, or every term, I'm sorry, in the second numerator. All right, so if our denominators are not the same, We can't add and subtract until we make our denominators the same. So in order to do that, we need to find the least common denominator of the rational expression. So that's the least common multiple of the denominators, okay? So in order to add or subtract fractions with different denominators, we must rewrite the fractions by finding the least common denominator. For example, if we had to add 2/9 plus 7/15, we'd have to find a number that's a multiple of 9 and a multiple of 15. The smallest such number. We can use any one, but we usually want to find the smallest one. That number is called the LCD. Once we get that, then we'll write both expressions with that LCD. In this case, it would be 45, okay? One way that we can find this, well, I just said 45 really quickly from my head because I thought about what are the multiples of 9? What are the multiples of 15? Another way we can do that is looking at the factorizations. So I want to look at this example that's done with numbers, and then we'll look at an example that's done with variable expressions. We have 9. 9 is equal to 3 times 3. 15 is equal to 3 times 5. You want to look at each unique term, in this case, each unique prime number, so the 3 and the 5, which whatever the maximum number of times each term shows up in an expression, that has to be included in the LCD. What do I mean by that? Looking at the 3s, 9 has 2 3s, 15 only has 1 3. In order for a number to be a multiple of 9 and 15, it has to have at least 2 3s because 9 needs 2 3s. So the LCD has 2 3s, okay? What about 5s? 9 doesn't have a factor of 5 at all, but 15 has a 5. So in order for a number to be a multiple of 9 and 15, it has to have at least 1 5. When you multiply those all together, you get 3 times 3 times 5, which is 45. Once you have your common denominator, or your least common denominator, then you want to rewrite your expressions, your original fractions, by multiplying so that each of the fractions has the new common denominator. For example, if we start with a denominator of 9, we want a denominator of 45, we have to multiply by 5/5. If we start with 15 and we want to go to 45, we multiply by 3/3. Once you have your common denominators, it works out very similar to what we did in the last expression. So let's highlight this. Finding the least common denominator for our rational expressions are 3 steps. 1, you want to look at each of your denominator, factor the denominators completely, and then line up common factors, okay? So that means if, you know, how many x's, how many x plus 1s, how many x minus 1s, how many 3s, whatever, line up all of the factors. And then multiply 1 factor from each column. What does that mean? If we go back to what I had up here, where I kind of have this stuff circled, I'll erase it. When we say line up things, it means literally line up the 3s, line up the 5s. That gives us 2 different columns. You need to select some 3s and some 5s. How many? The maximum number of times the factor or the number appears in the factorization in each column. So we have 2 3s versus 1 3. We take 2 3s. We have 0 5s versus 1 5. We'll take 1 5. You have to do this for every column for each factor that you have. All right, we'll do some examples where we play around with this. We can look at example, let's look at example 4 that's done for us in the book, and then we'll jump into some practice problems. So for the first expression, we want the least common denominator for 1/x squared y and 1/xy squared. So you're going to factor each denominator as much as possible. The first one is x times y, and the second one is x times y times y. So you're going to look at these separately. Look at the x's and then look at the y's. For the x's, one factorization has x times x, the other has just 1 x. You want to take whichever factorization has the most x's. So that would be x times x. Similarly for the y's, the first one has just 1 y, the second factorization has 2 y's. You're going to take the one with the 2 y's. And then multiply all of that together. x times y equals x squared times y squared. That would be your least common denominator. That's it. For the second two expressions, x plus 3 times x minus 3. I'm sorry, x plus 3 times x minus 2. These terms are factored as much as possible. We're not going to break it up to x and a 3 because that's x plus 3, not x times 3. So these are already factored as much as possible. Okay. When we look at the factors of x plus 3, it's just x plus 3. The factor of x minus 2, it's just x minus 2. So we end up having to just multiply those two together to get our LCD. X times 3 times x plus x minus 2. And then for the last expression, where's the problem? Okay, we have 1 over x squared minus x over 1 over x, I'm sorry. So let's compare these. We have x squared minus x and x. If we factor them, x squared minus x is x times x minus 1, and x is just x. So when we compare for the LCD, we need to have an x, because both of these have one x, okay? And then for the x minus 1s, we need to have an x minus 1. So the least common denominator is the x times x minus 1. So after finding your least common denominator, let's look at it with this last problem. We said the least common denominator is x times x minus 1. How can you rewrite the original expressions with that common denominator? Well, the first one already had that denominator. There was nothing to do. But for 1 over x, we want our denominator to be an x times x minus 1. It already has an x. So we need to multiply by x minus 1 over x minus 1. Then we have the expressions 1 over x and x minus 1 over x times x minus 1. They look different, but they simplify to the same expression. But the second one now has our common denominator that we want. All right. Let's jump into doing some of these our own. To these, remember, we're being asked to do two things. First, we have to find the least common denominator, and then we have to rewrite each expression as equivalent rational expressions using the least common denominator. So for part A, let's see, do we have one down here? I'll try to do them down here. For part A, the LCD, actually, I don't know if I'll have enough space at the bottom to do everything. So let's just start at the top here. For part A, we have x squared y and xy cubed. The numerator is x times y. I'm sorry, the first denominator is x times y. The second denominator is x times y times y times y. We need, where's the most number of x's? 2 x's and 3 y's. So the LCD is going to be x squared times y cubed. For part B, we have the denominator is x minus 3 and x squared minus 9. X minus 3 factors to just x minus 3. X squared minus 9 is x minus 3 times x plus 3. So the LCD would be, well, we need at least one x minus 3, and we also need the x plus 3. So x minus 3 times x plus 3 is our LCD. All right, that's part 1. Now, what does this mean for rewriting these expressions? 2 over x minus 3 and 3 over x squared minus 9. Well, the second one is nice because the denominator is already what we need it to be. That's 3 over x minus 3 times x plus 3. Nothing else to do there. That's written with our LCD. But for the first expression, we have 2 over x minus 3. We want to write this as something over x minus 3 times x plus 3. We have a factor of x minus 3 already. That means we need to multiply this expression by x plus 3 to get our common denominator. We should have parentheses there too. All right, so this gives us 2 times x plus 3 over x minus 3 times x plus 3. Now we have equivalent expressions that have a common denominator. All right, so for the last one, our two denominators are x squared plus x minus 12 and x squared plus 10x plus 24. These factor to, the first one is x plus 4 times x minus 3. And the second expression factors to x plus 4 times x plus 6. All right, so for the LCD, actually, let me write this slightly differently because I do like to line up the common factors, x plus 6. All right, so for the LCD, every unique factor that appears in one of these factorizations has to be in an LCD. What do I mean by that? These factorizations have an x plus 4, an x minus 3, and an x plus 6. All of those have to be included in the LCD. The question is how many times? In this case, it's going to be 1 for each. So we need 1x plus 4, it doesn't matter which one you circle, 1x minus 3, and 1x plus 6. X plus 4 times x plus minus 3 times x plus 6 is our LCD. Now the fun part. How can we take our original expressions, 1 over x squared plus x minus 12, which is 1 over x plus 3 times x plus 4 times x minus 3. We want to write this with our new common denominator. Okay, same for the other one. We're going to take 1 over x squared plus 10x plus 24. That factors to 1 over x squared, x plus 4 times x plus 6. We want to write both of these as something over x plus 4 times x minus 3 times x plus 6. So we're going to look for what whatever factors are missing from the denominator and multiply by that. Excuse me. So for our first expression, we have the x minus 4. That's good. We have the x minus 3. That's good. We need the x plus 6. So we're going to multiply by x plus 6 in the numerator and denominator. This gives us x plus 6 over x plus 4 times x minus 3 times x plus 6. For the second expression, in our denominator, we have the x plus 4. We have the x plus 6. We need the x minus 3. So we're going to multiply by x minus 3 over x minus 3. And that gives us x minus 3 over x plus 4 times x minus 3 over x minus, that should be at plus 6, x plus 6. How do we add and subtract rational expressions with different denominators? Basically the same steps that we did in the last problem, and then we'll add on to that at the end. We want to add or subtract the expressions that we get. So find the LCD. Rewrite each expression as equivalent rational expressions using the LCD. Those are the two steps that we did in the last example. From there, depending on what the problem says, you'll either add or subtract the rational expressions that you got in step 2, and then sometimes you can simplify. So then you simplify to get your final answer. For practice exercises 4, part 1, we have x over x plus 1 plus 5 at x minus 5 over x minus 2. First, you want to find the LCD. The LCD in this case, we can already tell those are two totally different factors. They have nothing in common, so we'll just multiply them together. It'll be x times 1 times x minus 2. If we want to write these expressions with the same denominator, x over x plus 1 plus 5 minus x over x minus 2, we want both of them to have a denominator of x plus 1 times x minus 2. So figure out what you need to multiply by to get that. For the first expression, we already have an x minus 1. We need to multiply, an x plus 1. We need to multiply by x minus 2. And if we multiply by that in the denominator, of course, we have to multiply the numerator as well. So we'll multiply the numerator and denominator by x minus 2. For the second expression, we need an x plus 1. So we'll multiply the numerator and denominator. Sorry, it's the wrong color and it's going to bother me. We'll multiply the numerator and denominator by x plus 1. All right, now the way that we have this written, our first numerator is x times x minus 2. Our second numerator is x minus 5 times x plus 1. And our denominators are both the same, x plus 1 times x minus 2. So we have a common denominator. Once we have a common denominator, then we can go to adding the numerators. Oh, I'm gonna need more room for this. The first numerator would be x squared minus 2x. I distributed the x. And then for the second numerator, we'll have an x squared minus 5x plus an x, so minus 4x minus 5. I just distributed and FOILed out those numerators. And then in our denominator, we have x plus 1 times x minus 2. You can FOIL it if you want to, but you'll have to factor it again later, so just keep it factored. All right, from here, what simplifies? So we end up with 2x squared minus 6x minus 5 over x plus 1 times x minus 2. That would be our final answer. All right, so example B is going to work out similarly, except now we're subtracting, so we want to be careful in the numerators. The LCD for example B, we have x plus 3 times x plus 2 as our denominators. It's just x plus 3 times x plus 2. So when we rewrite this problem, 4 over x plus 3 minus 5 over x plus 2, we'll have to multiply each fraction by the opposite denominator. So the first expression gets multiplied by x plus 2 over x plus 2. The second expression gets x plus 3 over x plus 3. And then we'll distribute the things in the numerators and then subtract. I'm going to add in an extra step here so that we can clearly see what we're subtracting in the numerators. The first numerator is 4x plus 8, and that's over x plus 3 times x plus 2, and then minus 5x plus 15 over x plus 2 times x plus 3. When we subtract, take all of the terms in the first numerator, 4x plus 8, and then subtract every term in the second numerator, minus 5x minus 15. And that'll be all over x plus 3 times x plus 2. Then from here, simplify and see if anything cancels out. We end up with 4x minus 5x, which is a negative x. And then 8 minus 15 minus 7. Negative x minus 7 over x plus 3 times x plus 2. We could factor out a negative 1 from the numerator, but it's not a huge deal. You can leave it like this as well. Then on to C. This one is a little bit more interesting. For the first two examples that we looked at here, our denominators didn't have any common factors. So the LCD was just the product of the two denominators. In part C, our denominators do have a common factor. So if we look at, I'll write it above, x minus 2, or let me write it this way. We can factor these denominators. We have x over x minus 2, and then minus 2 over x minus 2 times x plus 2. So we can see that one denominator has just an x minus 2, the other one has an x minus 2 and an x plus 2. So we need both of them to have the x plus 2 as well, okay? To make that happen, we're gonna multiply this first expression by x plus 2. Then we'll have common denominators, x minus 2 times x plus 2. The second expression doesn't need to be multiplied by anything because it already has both factors in a denominator. This gives us x squared plus 2x over x minus 2 times x plus 2 minus 2 over x minus 2 times x plus 2. Then when we subtract the numerators, x squared plus 2x minus 2 over x minus 2 times x plus 2. This does not factor. The numerator doesn't factor anymore. So this will be our final answer. All right. And then we have lots of silence today. I mean, there's always a lot of silence in this class, but maybe a little bit more silence than usual. So I want to pause here. Are there any steps that are unclear? Does everyone understand? Do you see why I'm multiplying by the terms in red that I'm multiplying by? Do you see how we're finding the common denominator? Any questions at all? All right, then we'll do two more of these that kind of simplify a little bit more at the end. So last two, it says, adding and subtracting rational expressions with different denominators. Same thing that we did before, except these denominators are a little bit funky, so we have a little bit more to do to figure out our LCDs. Starting with the first expression, 1 over x squared minus x minus 2 plus 5x over x squared plus 3x plus 2. We want to factor these denominators. So this is 1 over x minus 2 times x plus 1 plus 5x over x plus 2 times x plus 1. All right, so when we're looking at the denominators, we want them to have all of the same factors. If it's helpful for you, you can come off to the side and try to list out what should be in the LCD. Each of these unique factors has to appear. First, both of these have an x plus 1, so that's good. We have an x plus 1, okay? We also need an x minus 2 and an x plus 2. Those are all of the factors that appear in the denominators. So looking at what we have in our denominators versus what we need in our denominators, we need x plus 1 times x minus 2 times x plus 2. Whatever factor is missing, we have to multiply by that. So in the first expression, we have the x minus 2, we have the x plus 1, we're missing the x plus 2. So we'll multiply this one by x plus 2 over x plus 2. In the second expression, we have the x plus 2, we have the x plus 1, we're missing the x minus 2. So we'll multiply by x minus 2. And then this gives us x plus 2 over x minus 2 times x plus 1 times x plus 2 plus, this is 5x squared minus 10x over x plus 2 times x plus 1 times x minus 2. All right, but now our denominators are the same. Bigger expressions, but the denominators are the same. We can combine these numerators. This is addition, so we're just adding all of the terms. X squared, or x plus 2 plus 5x squared minus 10x all over x minus 2 times x plus 1 times x plus 2. If we rearrange these terms and simplify, this is 5x squared minus 9x plus 2 over x minus 2 times x plus 1 times x plus 2. Ta-da, the end. In part B, we have negative 2x minus 2 over x squared plus 2x minus 8, and then negative x minus 1 over 2 minus x. So I can already tell we have a 2 minus x there and an x minus 2 somewhere else. We might have to factor out a negative. All right, if we factor these expressions as much as possible, the numerator is negative, not that it matters much, 2 times x plus 1 over, the denominator here is x minus, or x plus 4 times x minus 2. And then we have minus x minus 1 over negative x plus 2. Okay, so now that we have the correct denominators, we can see that they both have an x minus 2. That's good. This one has an x plus 4, and the second one doesn't. So we just have to multiply the second expression by x plus 4. That makes this a whole lot simpler to deal with. This would be negative 2x minus 2 over x plus 4 times x minus 2. We still get the plus here because the two negatives are going to come together. And then we have plus x minus 1 over x minus 2. And we have to multiply now by the times x plus 4 over x plus 4. All right, this is nicer to multiply. Previously, we would have gotten cubics and it would have been doable, but just would have taken a little bit longer. All right, this gives us negative 2x minus 2 over x plus 4 times x minus 2 plus x squared plus 3x minus 4 over x minus 2 times x plus 4. Putting everything in the numerators together, we get negative 2x minus 2 plus x squared plus 3x minus 4 over x plus 4 times x minus 2. Keep that common denominator. And then our numerator is going to simplify to x squared plus x minus 6, and that's over x plus 4 times x minus 2. Now, at this point, x squared plus x minus 6 actually does factor. That factors to x plus 3 times x minus 2. So this one can be simplified a little bit more. This is x plus 3 times x minus 2 over x plus 4 times x minus 2. The x minus 2's cancel, and our final answer for our final problem of the day is x plus 3 over x plus 4. Ta-da!